My name is Tayeling. Today I'll be presenting the topic I've chosen, which is securing multi cloud environments, strategies for effective threat mitigation. In this slide, we'll see the introduction. The cloud computing has fundamentally reshaped how organizations manage infrastructure, software, and services. Traditionally, many companies operated within a single cloud provider, such as AWS, Azure, or Google Cloud. However, increasingly, they are moving toward a multi cloud strategy where services are sourced from multiple providers. This trend offers a multiple benefits, which is greater flexibility, reduced vendor lock-in, and optimized performance. However, with these benefits come a new generation of security challenges. Today's cyber attacks are more sophisticated and often exploit misconfigurations and inconsistencies in cloud environments. My project explores how organizations can strategically mitigate these threats with a focus on key technologies, case studies, and future proofing trends. Why multi cloud? Organizations often select multi cloud for reasons like geographic redundancy, cost control, performance optimization, and regulatory compliance. For example, a global e commerce company may run its customer analytics on Google Cloud, store backups in AWS, and use Microsoft Azure for enterprise collaboration tools. This setup reduces reliance on a single provider, which ensures the workload distribution and minimizes the risk of total failure. However, operating across platforms means that IT and security teams now need to manage multiple IAM systems, encryption policies, and also monitoring tools, and this is where the complexity begins. In this slide, we will see the multi-cloud trade landscape. Each provider has a unique ecosystem. This diversity can lead to inconsistent configuration, gaps in security policies, and blind spots. The common traits are misconfigured identity and access management IAM, unsecured or exposed APIs, inadequate or fragmented monitoring, and weak policy enforcement. These issues are often exploited by cyber criminals who scan for the weakest link in a multi cloud setup. In this slide, we will see a real world example of a case study, which is Capital One breach in 2019. An attacker exploited a misconfigured web application firewall (WAF) on AWS by leading to a data leak of over 100 million customer records. This breach wasn't caused by a sophisticated exploit. It was a simple misconfiguration. Now imagine this in a multi-cloud context. If similar misconfigurations happen across multiple providers, the risk and exposure multiplies significantly. This case emphasizes the need for consistent security policy enforcement, uniform monitoring, and least privilege access, regardless of which cloud is used. In this slide, we will see the key security challenges. Multi cloud environments face a unique set of security challenges. Let me walk you through the major ones. First, IAM fragmentation. Each provider manages users, rules, and policies differently, making it hard to enforce a consistent least privilege model. Second, policy inconsistencies. Security rules may vary, leading to a loopholes attackers can exploit. Third, monitoring complexity. Without a centralized dashboard, teams can't track cross cloud activity in real time. Human errors and misconfiguration. Too many interfaces and consoles increase the risk of mistakes. Lastly, compliance gaps. Regulations like GDPR or HIPAA require unified governance, which is hard to achieve across multiple CSPs. These issues demonstrate why multi cloud security must be treated as a separate discipline, not just a scaled up single cloud. In this slide, we will see the encryption strategy, which is one of the core pillars of a cloud security. Data must be encrypted both at rest and also in transit. This is the standard. However, in a multi cloud environment, different providers have different default encryption algorithms, key management protocols, and also compliance rules. Many organizations now implement two concepts. One, bring your own key BYOK, which is you provide and control your own encryption keys. Second, hold your own key HYOK. Your keys never leave your control or hardware module. The key takeaway, encryption isn't just about scrambling data, it's about maintaining ownership and uniformity across platforms. Next is Identity and Access Management, or IAM, which is determined to get who gets access to what. Inconsistent IAM setups can lead to identity silos, overprivileged accounts, and privilege escalation attacks. The solution: Identity Federation and Single Sign On SSO using protocols like SAML or OAuth 2.0 or OpenID Connect. These standards allow users to authenticate on and gain access to resources across AWS, Azure, GCP, and others without having separate accounts. Additionally, implementing RBAC, role based access control, or ABAC, attribute based access controls, enables organizations to follow least privilege principles more effectively. Next slide is CSPM tools. Cloud Security Posture Management (CSPM) tools plays a vital role in securing multi-cloud setups. Tools like Prisma Cloud and Microsoft Defender for Cloud offer misconfiguration detection, continuous compliance checks, real-time alerting and remediation, unified dashboards. CSPM helps an organization to enforce policies to automatically and monitor configurations continuously, reducing both risk and manual effort. In this slide, we will see Zero Trust Architecture ZTA, which is becoming a cornerstone of cloud security. Its principle is very simple: never trust, always verify, even for internal users. ZTA assumes that every user, device, or network could be compromised. In practice, this means multi-factor authentication, MFA, micro-segmentation of networks, strict access policies for every session, continuous verification of user identity. In a multi-cloud environment, ZTA ensures that each cloud segment is protected independently, limiting lateral movement and also exposure. In this slide, we will see AI-based threat detection. AI is transforming cloud security through automation and prediction. Traditional monitoring tools rely on signatures or manual thresholds. AI, on the other hand, is able to learn normal patterns of a behavior, detect anomalies instantly, correlate events across multiple clouds, and also trigger automated responses. For example, an AI engine could detect that a user from Malaysia suddenly logged into a US-based admin console at 2 a.m., a clear red flag. These intelligent systems are increasingly critical for securing dynamic, decentralized environments. In this slide, we will discuss about the Secure Access Service Edge or SASE framework. As defined by the Gartner, SASE converges networking and security into one cloud native service. It combines ZTNA, Zero Trust Network Access, CASB, Cloud Access Security Broker, CWG, Secure Web Gateway. SASE supports location independent, scalable, and policy driven access, making it ideal for remote workforces and decentralized teams. Cisco and Palo Alto are leading vendors in this space, and adoption is growing rapidly among Fortune 500 firms. In this slide, we will see the post quantum encryption. With the rise of quantum computing, traditional encryption algorithms like RSA and ECC are vulnerable. Quantum computers could break current encryption in minutes using algorithms like Shaw's algorithms. That's why post quantum cryptography (PQC) is now of strategic focus. Standards organizations like NIST and NISA are recommending lattice based and code based algorithms that are resistant to quantum attacks. Organizations that store long term sensitive data in the cloud must start adopting quantum safe encryption to protect future confidentiality. In this slide, we will see the benefits and also limitations of multi cloud. So, what's the bottom line? Benefits of multi cloud. First, improved resilience and uptime. Second, cost optimization through competition. Third, better regulatory coverage. And the limitations, first, higher complexity in configuration and operation. Second, fragmented feasibility and oversight. Third, increased training and personal needs. Multi cloud isn't just about adding clouds, it's about managing them securely and also strategically. In conclusion, multi cloud architectures are the future, but they bring new security risks that must be tackled proactively. To secure them effectively, organizations must implement unified IAM and encryption, zero trust principles, CSPM tools, AI based analytics, quantum resistant cryptography, and also frameworks like SASA to integrate security with access. It's not about avoiding multi cloud, it's about mastering it. And that means treating security as an evolving, continuous process. That's all from me. Thank you.